A very good morning to all of you. So let's continue the next topic, that is the population growth. Yesterday we had discussed about the various attributes of the population. Now I am going to discuss with you the population growth. So size of the population depends basically on the food availability, predation pressure and the weather. So size of the population is not a static parameter, it may be changed from time to time. So population density is equal to the number of individuals or the percent of biomass, how much percent of biomass is there. So population depends upon the following basic processes. The process on which the population density it depends. The first one is the natality. We discussed about the natality rate yesterday. So natality, it is the number of the birth during a given period of time that increases the population density. So the birth rate is equal to the number of the individuals that took birth in a given period of time. So next is the mortality. That is the death rate. The definition is same for it also, but the difference is that it is a number of the deaths in a given period of time that decreases the population density. Next new term that we have to discuss is the immigration. What is this immigration? So immigration is the number of individuals of the same species that are added to a habitat in a given time period, which increases the population density. Suppose sometimes what happens ki in a particular geographical area, the people or the organisms, they come from the another country or the state or another place, another geographical area. They are not the native people of that particular place, but they are there for any reason, maybe the food habitats in the case of organism, and maybe the studies or another job occupations and whatever, they come to the another place, that is known as the immigration. And the next term is the immigration. Now it is the opposite of immigration. So immigration is a number of individuals of the same species that move to the different habitat in a given period of time. So this decreases the population density. So the population density is given by the equation. On the basis of these four factors or the processes, the population density is given by NT equals to N0 plus B plus I minus D plus E. So NT is equal to the population density here. The meaning of NT is the population density. N0 is the population in beginning or population at the starting point. B is for birth. I is for immigration. D is for death. And E is for immigration. So this equation shows the population density will increase if the number of the births and the immigration are more and the number of death and the immigration rate are will this, otherwise it will decrease. अगर ये जो हमारे पास फैक्टर है बर्थ और इमिग्रेशन रेट अगर ये ज़्यादा है तो पॉपुलेशन इंक्रीज़ करेगी, और अगर हमारे पास डेथ और इमाइग्रेशन रेट ज़्यादा है तो पॉपुलेशन डिक्रीज़ करेगी. सो विद द हेल्प ऑफ दिस इक्वेशन वी कैन फाइंड आउट द पॉपुलेशन density. Now next thing is the population growth models. Now what are the population growth models? So there are two models of the population growth. First one is the exponential growth. This topic is very important as these growth models are oftenly seen in your exam papers. So this is exponential growth and logistic growth. Two type of growth models are there. One is exponential growth and another one is the logistic growth. So let's discuss the very first one, that is the exponential growth. Now in this exponential growth model, so it is also known as the geometric growth, where and this model is common where the resources are unlimited. Resources are unlimited means there is lots and lots of space and food is available for the organism. So the species has the ability to realize fully to its innate potential to grow in number. तो जो अपने species होते हैं उनके पास food availability अच्छी है, resources जो है, स्पेस अच्छी है, तो वो अपना इनिट पोटेंशियल पूरा रियलाइज कर सकते हैं, इजीली यूज़ कर सकते हैं टू ग्रो इन द नंबर. सो द इक्वेशन फॉर द एक्सपोनेंशियल ग्रोथ कैन बी डिराइव्ड एज dn upon dt b minus d into n. So let b minus d, that is birth minus death rate, equals to r. So then we have an equation dn upon dt is equal to r n. Now here in this exponential growth form the equation will be nt, that is the population density, n0 e raised to power r t. So now what is this? N is equal to the population size, and t is equal to the population density after the time t, and 0 is equal to population density at the time 0. R is the intrinsic rate of natural increase. Intrinsic means जो natural rate है किसी भी चीज़ का increase होने का. E is the base of the natural logarithm, and then we are having B and D, that is birth and death rate. So जो R है that is an important parameter जिससे कि हम assess कर सकते हैं impacts of the biotic and abiotic factors on the population growth. So अगर हम plot करें graph exponential growth के लिए, then n जो है that is in relation to time is plotted on the graph, और ये जो graph है usually it is a J shape. So जो हमारे पास है इस तरह का J shape जो है graph आएगा, where dn upon dt is equal to r n, right? So this may be the graph and this one is the exponential growth model. So next is the logistic growth model. Now in the exponential growth model, as I told you, the resources are unlimited, but in this the resources are limited at a certain point of टाइम, सो नो पॉपुलेशन कैन ग्रो एक्सपोनेंशियली। तो जो एक टाइम पीरियड पे आके जो हमारे पास रिसोर्सेज है वो जो है कम होने शुरू हो जाते हैं या ख़त्म होने शुरू हो जाते हैं। सो दिस ग्रोथ मॉडल इज़ मोर रियलिस्टिक, क्योंकि ऐसा तो कभी नहीं होएगा कि कोई चीज़ जो है वो कभी ख़त्म ही ना हो, राइट। सो इकोसिस्टम और इन्वायरमेंट और एनी हैबिटेट that has a limited resources so as to support the particular maximum number of individual, that is known as the carrying capacity, which is usually denoted by K. Carrying capacity, and it is usually denoted by capital K. So capital K means the carrying capacity, and every ecosystem or environment, or you can say the habitat, that may have the limited resources to support a particular maximum number of individuals in a carrying capacity. So n जो है plotted किया जाए अगर relation time graph में, so we will get the sigmoid curve, जिसे हम Verhulst per logistic growth भी कहते हैं। और ये जो curve है हमारे पास, it may be sigmoid like S shape. I'm not so good at the drawing, so but I'm trying to draw it. So just just a S shape, that is sigmoid curve. So this is the sigmoid curve. Then the equation for this is equal to dn upon dt, and we get Rn, that is a constant, and then we have the equation K minus S. K means the carrying capacity, N means the population size. It should be divided by K. So this is the equation for the logistic growth, where N is the population density as we did in the exponential growth system, then R is the intrinsic rate of the nature, K is the carrying capacity, and N is the population density at a particular time. So this graph shows lag phase, means the phases of acceleration and deceleration. Sometimes there is a acceleration and sometimes there is a deceleration, and finally the population density they reaches their carrying capacity. So this is all about the population growth models. Thank you students, and have a nice day.